Assalamu alaikum and hi there, this is the video regarding our MEC 523 project, which is self-watering plant system. We are from Faculty of Mechanical Engineering. We are consists of 3 members. Did you know? The Earth has more than 80,000 species of edible plants. 80% of the Earth's original forests have been cleared or destroyed. Plants, like all living organisms, have basic needs, a source of nutrients as food, water, space to live, air and optimal temperatures in order to grow and reproduce. Plants really need water for same reason that all living things do, to dissolve the chemicals they use to do their biology. Plants also use water current up the plant for transport, which evaporates water out the leaves, so they need water for that reason too. Plants can't live without water, but how often they need to receive it to stay alive varies tremendously. At one extreme are vulnerable, fast-growing plants like seedlings, which may need water several times a day. Problem statement. Sometimes a working person always forgets to water the plant in his or her house, and thus the plant will wither and eventually die. People who need or wanted to go to vacation or business trips does not have someone to water their plant as they are out of the area. Objectives. First, to ensure that the plants will stay healthy and always in the best condition. Second, to facilitate the plant's owner to water their plants because it is easy and convenient. SolidWorks design. This is the exploded view of our self-watering plant system project. As you can see from this point of view, you can see clearly that there is water inside it which it will be used to water the plant. Product assembly. This is from another point of view, so as the moisture sensor detected that the soil is not moisture, the water from below will be automatically pumped using motor and flow upside through the tube and finally flow out to the soil until it is moisturized.
Electrical wires are conductors that transmit electricity from a source to electric appliances. An electric motor is a device used to convert electricity into mechanical energy. Soil moisture sensor consists of 2 probes that are used to measure the volumetric content of water. The 2 probes allow the current to pass through the soil, which gives the resistance value to measure the moisture value. An infrared sensor is an electronic device that measures and detects infrared radiation in its surrounding environment. The Arduino R3 is a microcontroller board based on a removable dual inline package DIP. It has 20 digital input-output pins, of which 6 can be used as PWM output and 6 can be used as analog input. Circuit diagram and coding. In this project, there are 11 components. First is battery 9 volt. Second, Arduino Uno, IR sensor, DC motor, LED 3 transistor, temperature sensor, LCD, NPN transistor, potentiometer, and relay. First, I will explain about IR sensor. IR sensor have 3 pins, which is power, ground, and signal. Power refer to green wire, ground refer to orange wire, and signal we can refer to blue wire. Signal, it connect to pin A1 and it receive the signal from the coding. An IR sensor need 5 volt for supply, and it can take the supply from the Arduino Uno, which can consist 5 volt for supply. Second, Motor use battery 9 volt to increase the voltage supply, so we use the battery 9 volt. Then we connect to the relay to separate the 5 volt and 9 volt. Relay only needs supply 5 volt from the Arduino. Signal from the motor sent to digital log 2. And in this project, there are one input, which is soil moisture sensor, and 3 output, motor, which is connected to relay, battery, and NPN. LCD screen, which is connected with potentiometer and transistor for SOCD. And lastly, LED, which is connect with digital pin 8. Next, I will present the coding. From the beginning until the line 6 is define the sensor and the time. From the line 9, it declare the input. For the line 10, it declare LCD with pin 12, 11, 6, 5, 4, 3. Next, for the line 13 to 16, we can see it decline the water in low and water in output for 9.6 seconds, and then LCD begins. Then we move to the line 45. In the line 45, it starts with the code. If the sensor value greater or equal to -, so the water will dispense from the motor. Next, it go for the delay for 2 seconds, motor on, and watering start. When water low, so the LCD will show that the motor will off. Next, it will go to the line 48 until the end. It show the message that sends by the sensor to the LCD to make sure that the soil is in good condition. As you can see, when the motor is on, watering start. When soil in a good condition, so the motor is off, delay for the 2 seconds, and then end the code.
Total cost for this project is 32 ringgit and 70 cent.
Moisture sensor, IR sensor, Arduino Uno, and DC water pump. Okay, let's go. Put the DC water pump into water tank. Put the moisture sensor into the sand. Connect Arduino Uno with power supply. And switch on. If the sand is dry, DC water pump will pump out water through water tube. When the sand is wet, DC water pump will stop pump the water. Thank you.